There's a low voltage switch cutoff, just like on your CNG buses. There's a low voltage cutoff, and if you cut that off, it's going to shut the bus down. And so whenever we go through the safety procedures here, we'll be talking about that. The ground, the V2G. V2G is pretty much on any, every electric vehicle has a V2G. And that, if you're going to choose a component to steal off of an electric vehicle, choose the V2G because that's the top secret part of the car. I wanted to open one up on our bus just to see how it looked, because I've seen inside most of the other components with our bus, and they go, no, nobody's allowed to open that, it's top secret. And I said, well, I'm going to go see how these other vehicles, search online to see what V2Gs look like, and everybody's the same way. They say, no, nobody's allowed to open those up. Like if you get a Volt or a Bolt or a Tesla, they all have vehicle V2Gs, but they say you're not allowed to open those. So that's where the technology is. And all it is an inverter, pretty much. Inverts the power from DC to AC and AC to DC.
Okay, I have a quick question.
Yes.
That low voltage you were talking about, the shutdown, is that to shut the bus off? Or why would you need to do that?
In case of an emergency, or if you're gonna service the bus, yeah, I'll get into that, why, and stuff. But, you have your 3-in-1, and I'll show you a picture of all these things here in a minute. 3-in-1, you have a VCU, the vehicle control unit, L, if you see L or R, it's meaning left or right. SOC, this is gonna be very important to you as a driver, or for the drivers to know. On the dashboard here, on the page right here, this side here, this is the right-hand side, the lower portion of this page is the right-hand side of the cluster. It looks like a speedometer, but it's state of charge is what it means. And it's telling you the percentage that the high voltage batteries are at. And so now, sometimes those can get out of calibration. And so I'll show you how to calibrate, make sure that's calibrated right, because you don't want it reading 90% and you only have 20%. Because then you're going to be out driving and the bus is just going to die for unknown reasons.
Does the gas gauge kind of speed?
Yes, yes. So it's the what the percentage is of the battery. And these books are for you to keep.
So how will we know if it's not properly calibrated?
When you start the bus, when you first turn the bus on, make sure the needle there starts at 0 and goes up to where it's going.
Okay.
If it's past 100, it's out of calibration, you know for sure. But the battery can be so low, but it's still reading at 100, or 90, or 80, or 70. But you only have 10, 15, 20% if it's out of calibration. So that's one thing that I would teach the drivers. You all are the trainers, right? Or are you just drivers?
Some of us lead drivers and
Okay. But
supervisor.
You're gonna be showing others how to
Oh,
do this also, right?
Eventually, yes.
Hopefully.
Yes.
Okay, so when you first start the bus out, you sit down in the driver's seat, there's gonna be a switch to your left, and I'll show it to you in a minute. It's called a master switch. It should be in the off position. You're gonna turn it to day run or to night run, depending on when you're driving. The bus is gonna power up, all the lights and everything are gonna come on. Now, the bus is not drivable yet until you start the bus. The way you start the bus is you press the brake down, the little power button will turn green. You hit that and let both the brake and the power button go at the same time, and the bus starts up into what we call OK mode. And I'll show you in a minute. But when you first turn that master switch on, watch the SOC gauge. If it starts anywhere besides on 0 to go up, if it starts at 10, it's not calibrated. Or if it starts at 20 or whatnot, it has to go all the way back to 0, then come back up.
So if it's not calibrated, how, is it something on the
I'll show you, it's really easy. All you do is toggle the master switch on and off. You turn it on, turn it off, turn it on, turn it off, until you get that needle to go back down to 0. So you just toggle it on, wait a few seconds for it to go up, toggle it off. But if you notice that it's not starting at 0, just turn it on, turn it off, and watch it go back down.
So it's basically a reset.
Mhm.
sort of.
Yeah, yeah, it's recalibrating.
Right.
So, and I'll when I get out there, it's really easy. So
So the needle that you're talking about is the needle on the
the needle
SOC.
is this needle here. Whenever you turn
Yeah,
when you
see
first
that.
turn that master switch on, all these lights are going to come on. The needles, all these needles are going to calibrate. But this one here, if it's out of calibration, it might not go back to zero. It might be over here when you turn it off. So it's gonna come back, when you first turn it on, it's gonna come down some and then go back up. It needs to come all the way to zero before it goes up to wherever the SOC is. Does that make sense?
Yeah.
So we have two different heating gauges here, temperature gauges. It's because the bus has three different cooling systems. Okay, the one gauge that doesn't have a gauge here is the battery cooling system. Our batteries are water-cooled batteries, or it actually uses antifreeze, but it's a refrigerant system up on top of the bus that keeps it cool. There's just an idiot light here, this light here, and I'll show it to you in a minute. The motor overheat. It's showing you that. Well, that's not for the batteries. I'm sorry. One of these others are for the batteries here, telling you that the batteries are overheating. If that light comes on, it's going to limit the power to the bus. But the other two systems here are pretty much identical. The reason why the left side is always going to run warmer than the right side is because the left side, on the left side of the bus, or the street side of the bus, the cooling system on that side is cooling the V2G, the drive motor on the axle, the air compressor, and the 3-in-1. So it has 4 units that it's cooling. On the right side, the temperature, that cooling system is only cooling the V2G on the right side and the drive motor on the right side. It only has 2 units, two different things that it's cooling. The other side has 4. So that's why, oh no, this side's warmer than that side. It's normal. It's normal. As long as it's not in the red, it's okay. As long as it doesn't get up here into the red, it's okay. And so just don't be alarmed if one side is warmer. Now, if the right side's warmer than the left, I might be concerned about that, but I do. Always put this thing down. Your miles, your speedometer, your SOC, state of charge, rear compartment door. If any of the doors on the bus are open, the interlock locks the bus down, so you can't drive it. And if this rear compartment door is open, it won't drive either. And so,
Is that like a safety sensor?
there's a sensor in the back that senses that the door's not closed. Now the door might be closed but not locked, and then you can still drive it as long as it's closed and it's touching that sensor. But we should make sure as drivers that those doors are locked and fastened down, because there's just little locks on them. Driver's seatbelt. This might flash at you. There's no buzzer for it that I noticed. I drove the bus around the lot just a little bit yesterday. So some of the drivers was like, we don't use our seatbelts here. I'm like, well, that's on you. I'd still be using it. I always try to err on the side of safety. But the light will flash at you. Kneeling. So if the bus is kneeling, it's going to indicate that it's kneeling. The parking brake indicator that the parking brake is applied. And these two here are also with the kneeling part. It's more telling you that the bus is not at the right height. Maybe you've raised it and it hasn't come back down, or you kneeled it and it hasn't come back up to the right height yet.
Okay.
The bus won't move if it's kneeled.
That's my question.
I didn't know the answer yesterday when they asked, but so we went out and drove it. Because different customers request different things. They want the bus to be able to move while it's doing it. Maybe they have to duck down under a bridge. Because we had 2 K11s in back east two different drivers, went under the same bridge, but knocked some of the batteries off the top of the bus. And no problems with the batteries though. Our batteries are very robust, and they're pretty much the safest batteries in the industry. Just,
How many batteries on top of that bus?
on top?
They said the batteries are on top, right?
No, they're all through the bus.
So they're in different areas of the bus.
If you look on this page here, in this small book here, all this red here
Yeah.
are the batteries. So there's batteries on the top front section of the bus. There's batteries right in front of the articulation, and then there's batteries right behind the back wheel under the chassis, and then there's batteries right above the rear compartment door, the upper part of it. There's
Now,
batteries
are
there.
they spaced out, put in different places that way because those batteries will specialize in various components of the bus?
No.
Oh, it's all
They're-
still on one system?
The curb side of the batteries on the curb side are all wired together as one big battery.
Okay,
The ones on the left are wired together as one big battery, so we call it 2 packs. We call your bus a 2-pack battery, or a 2-pack bus.